Okay, so we are asked to find the y dx by first principle. Okay, the first thing to do without wasting time is to say that let y equals to f of x, because it's actually a function of x, and that is f of x minus 1. Okay, now next is to get our f of x plus h, because these are the two things that are really necessary in first principle. F of x and f of x plus h, they are very necessary. So our f of x plus h is going to be 5. Remember, this x plus h is replacing x. So we are going to do the same thing, replace this x by x plus h minus 1. Hope you can see that. And when we expand this is going to give us 5 times this, 5x, 5 times this, 5h minus 1. And then next we get their subtraction, f of x plus h minus f of x. So let's do their subtraction now. F of x plus h, that is 5x plus 5h minus 1 minus f of x, f of x, 5x minus 1. And then if you expand this, minus times this, minus 5x, minus times this, plus 1. And then what can you notice? You'll notice that this 5x will cancel out minus 5x. This minus 1 will also cancel out 1. So that I am left with 5h. Okay, so let's go now. Recall that our formula says that the y dx is equals to limit. Remember, that's our formula. So let's put it down, which means as h tends to 0, remember that. So we have gotten this as 5h all over h. Remember, f of x plus h minus f of x, we have gotten it here as 5h. So I'm replacing it, and that gives me limit. This cancels this. I'm left with 5. Okay, and therefore my answer is 5 because.
And this is simply because the limit of a constant is that constant itself. So the limit of 5 as h tends to 0 is 5. Thanks.